Alright, now it's re-recording again. Picking up where we left off. Line side power, right here. Twisting it, tighten it up. Tight. Comes into L1. Bless you.
Bless you.
Okay. Neutral.
So you connect them next to the aux?
Yeah, because right here it's L1,
Yeah.
L2, and then ground.
And then neutral is the third one, right?
The neutral is the second
Or
one.
second?
Yeah, L2.
I mean, yeah, neutral and ground, right?
Yep.
Yeah.
Tighten it up. Tight. Tight. Ground.
Can you repeat what the PLC is called?
This is a micrologix 1100 Series B. Okay, so now we at least have power coming to energize the PLC. That's the first step. Now we have to energize all of our buttons. So take a source of energy. And I'm only going to do stop start for this just so you can get the concept of it, because it's the same thing over and over and over. Constant source of energy. Comes into a button. You can see it real good on the video we're doing. Out of the button.
Your push buttons are on the bottom.
Huh?
Your push buttons are on the bottom.
But it's perfect. The camera is perfect on my video camera. Comes in.
Your power goes into the push button and then out into the PLC.
Yep. Because the PLC is what does all of your connections. And that's the input 0. Now, our PLCs take 120 volt input, and we have relay contact outputs, because that's the PLC that I bought. Now, let me get this one here. Bless you.
Bless you.
Right here. Tighten it up. Tight. And on the top, to get a difference of potential, you need that common, right? That's how voltage is checked. And it's labeled on the PLC, AC common. So, take the neutral wire over to the common. So now you got power, goes into the one set of normally closed contacts, out of the contacts, into the PLC. See if we can zoom out a little bit on this camera. There you go. Now we have the stop, or what we're going to use as our stop. You do the same thing. Constant source of energy. End of the button. on this address, it is I:0/1. Because there's no slots, so it's a 0. And it's at the first, or the screw labeled number 1.
Everything's labeled, huh?
Everything's labeled.
Is that just so it makes it easier when you enter in a computer?
Yeah, without that, if you don't know the address, how are you going to ever identify the specific location? Everything's got to have an
So
address.
with that address on top, you enter in the computer and then you put it, so like the one you just did right now, the computer's gonna know it's an open set of contacts, or how does that?
You have to decide, is it an open set or a closed set in your program? So
Okay,
now you have
start
to, you have to start applying all of the logic.
So you say it's a start on the computer and the address for the start button is that where you just set it and then it'll be programmed for that?
No. You have to, well, let's worry about the wiring first, and then once we bust out the computer, this is how you address it. So this is specifically designed. Connect the wire here, take the wire here, go out of the wire here, or contacts here, up to there. That's adding the 2 buttons, and then we're going to show how to add all of it, and then the wiring's done. So if you go to the plant, you're like, we need to add a limit switch. So here's an example of a limit switch. It's got open contacts and closed contacts. Based upon what do you need, take a constant source of power into the limit switch, out of the limit switch, up to the input section. You want to add another button, like a job? Constant source of power, into the button, out of the button, up to the input. It's the same thing over and over. You have 600 inputs, you're going to do the same thing 600 times. Now, you're going to do outputs, right? These are contact style outputs, just like the ice cube relays we've used over and over and over again. So, gotta take constant source of energy to feed the bottom, right here. So we have constant energy right here. And it feeds a set of contacts right down here. That's power into the contacts. It has to turn something on. Oops. Let me see if I can pan up to get my light. That's the tower we're going to power. The tower power. It's interesting, huh? So, I don't know exactly which one goes to what. Can't really read the numbers. 2, 3.
You have a number?
Well, this one doesn't have, I'm not sure. It doesn't, it's just going to be an indicator. The wiring is the key part. So the wire that's going to go to the light bulb is going in. I'm going to use contact block set 0 right there. It's tight. And then, where's number 2? This looks like the red because it's wire labeled number 3, the third light. But you can't get nothing out of contacts unless you provide power into them. So, adding another wire of power comes in. Tighten it up. Make sure it's tight. Bring power into the contacts. And it's going to turn on a light. This is number 3. Goes right next to it.
An output, you just run it through the bottom instead of running it another wire from the top to the light.
So you got power, your source of energy comes into the PLC, it goes out of the PLC when it's programmed to do so to turn on your load. And don't forget, if you don't have the neutral for your lights, it can't work. You have to have the hot and the neutral for everything. Well, in general, unless you have something like 240 or something.
If it's 240, you don't need to?
Most of the time it's 240 like your dryer.
Yeah.
Well, the new plugs on a dryer have a neutral too. But if you have the old school ones where it's too slanted and the little bottom on there, then
Yeah.
it's only 2 hots in the ground. So it just depends. Most of the time that's what you're going to be working with. Now, we're not using the other 3 lights. Power coming into the contacts, power leaves the contacts based on the programming that you're going to do to execute all of the different commands. Questions on wiring it up at this point? Because this is, I just want, this part of the video, wire goes here, wire goes here.
Can I go there and look at it?
Sure. So it's just in and out. Just like the inputs, power goes into the button,
Out of the button.
out of the button up to the input section of the PLC.
So since it was stopped with the input.
Because
Ran
it's
it through the-
providing power
Yeah.
information into the
Yeah,
system.
So you got your power from here, you brought it in there, out, and right back up here, 'cause
Mhm.
it's an input, and then with the light, it's an output, so you ran it from the bottom.
And that's on this PLC.
Yeah.
If you have a
It
different
could be
PL
different, it could be outputs on top or.
Well, usually when you have like an SLC 500, it's an entire card.
Oh, is it?
So you literally pop the whole card out and then you put the card back in. It's usually like an input card or an output card.
Oh, okay, and that's what these are, considered like cards?
Well, we don't have a card because this is a modular. This whole PLC only costs like $700 total. You get one of the modular one, now they're like $4,000.
Oh, because you can replace some,
All the cards and they're expandable.
yeah.
So like, let's see, I mean, most pieces of equipment have, you know, lots of inputs and outputs. It's the same thing.
Yeah.
You know, if you can master this and learning it, oh, I need 600 push buttons.
Yeah.
Okay,
So is it,
from here to the push button, from the push button to the PLC, from here to the next one, and you do that same exact thing 600 times.
so like you do the lights, you ran your power and then you ran it right next to it, right? So
Yep.
this is.
Because they're, see how they're together? See? It's got a little bracket.
So it means they're tied in.
Yeah. That's in, so that's like a 1, and then the other is like the 3 or the 4.
Okay.
And that's all dictated by how you draw that program, or draw that contact in.
Yeah, you also have to be careful, because if you ran it, say you put it right there, or like close to here, and you ran it through the other channel, or whatever.
Oh, then yeah,
Then you're not gonna have any power to it.
right,
It's not separate.
because you, yeah, it'd be miswired,
Yeah.
right? Gotta go in, gotta come out. It's, and you see the little brackets on there? So that's where it says VAC or DC,
Yeah.
that's in, and then O/O out.
So it's pretty much just jumper, you just poof, right back into there's the power, whatever.
That, you take power into the contacts, and then it closes to fire whatever output you got.
Yeah, it's kinda hard to see right there, that's why I wanted to see it.
No, that's why when the video is basically designed, because it's only made for you guys.
Yeah.
We're all using the exact same thing, and you're going to be at the board. So at least if you look at the video, you can go, okay, it goes over here, and the
Yeah,
way we're
that's
talking
all.
about it, it'll at least get you to where you could wire it.
And you said this acts as a breaker, you said?
That ain't a breaker,
Yeah.
that's just
You said something about
bonding.
a breaker or something like that earlier?
Usually they would come from a breaker.
okay.
You're not gonna, in general, go, here, let me plug in this whole system. There's gonna be some form of a disconnect or something a little
Yeah.
bit more permanent than what we've got here.
Okay.
This is just a cord that got cut off of something else and we're using it.
So why did we run into here instead of right there?
Cause how are you gonna get all your wires back out of here?
Oh, yeah, that's a good point.
So that's if I was going to go buy terminal strips, and I looked them up this morning, so here's putting on the camera too. They sell this is $9 at Home Depot, and then they sell the little jumpers too. But I didn't leave my house early enough to make it to Home Depot, get through the
Yeah.
line before I had here this morning. And I did it this way yesterday, and I know it works, so I was like, well,
Yeah, it works.
it's not necessary, you know,
Yeah.
I mean, it wasn't a necessary item. But that would be something that's, when you're looking at it, terminating on these huge screws versus terminating on those little dinky ones. And then you don't have to do all those jumpers if you buy the part that literally slides into it and you
Yeah,
tighten
it's just
them
a little
all up.
bar that goes right here, right?
Yep. And since we didn't have it, now we got, you know, all those jumpers over the top.
So as of right now, the wiring is done with this?
That's it.
Hey, so you're saying that most plants and warehouses, they're gonna have those ones?
No, they usually have these, but they have the bonding jumpers.
Oh, wow.
It's the same thing. You just gotta take the power in and then go back out of
Yeah,
it.
like that, right? Out here, there, right?
Yeah, I don't wanna be helping you do that.
That just power, in,
Nah,
out,
that makes pretty sense.
up.
It's just hard to see like with the wire work.
Like a little.
Yeah, it's like it all just like shoot.
And I'm
It's
gonna,
easier than the start job.
because all of it's done in the programming.
Yeah.
So that's where, like, remember I was select, you better know how to do this
Yeah,
come
yeah,
next
yeah.
year. Now you can kind of see why I'm like, it all goes back to theory. You're not doing any of the jumpers to seal the memory.
Yeah.
You're not running wires through the timer relay base. Everything's done theoretically
Yeah.
now. So if you had a lapse in the theory, now it's gonna be like, oh man, I gotta learn how to wire this, pick up how that worked, and then master a new theory and terminology. Makes it a little bit different.
And like you said too, they're not always gonna be like that. They might be different.
They're going to be
So
different.
it's all, like you said, theory because.
This is the small, I mean, this is, it's a micro. I mean, and if you think about it, when you're going to these huge plants, when are they ever gonna have something that only has 6 outputs? I mean, just on our little potato machine, there's at least that many outputs. On the VFD, we've got more outputs than even here that are used throughout that little trainer. So I mean, it's all based upon scale and what you need.
Yeah.
Okay, last question before I put stop on this. That'll kill this video here, and then we'll restart with the connecting.
Good.
Okay, I'm going to push stop on this right here.